Okay, now that we know how to solve equations with logs and exponentials by hand, I want to go back and revisit a concept that we discussed earlier in another video. In another video, we discussed solving an exponential equation graphically by finding the intersection on the calculator, where we had some exponential function and it was set equal to some constant function, and we were trying to solve it by finding where it crossed. Now we have the tools to do this by hand. So in this example, we're going to talk about an account. We're going to discuss an account with an initial deposit of $5,500, and it earns an interest rate of 7.75%, and it's compounded continuously. So notice it says compounded continuously, so that I know that I need to use this formula rather than the formula that has the n in it, where it's compounded n times a year. The question is asking for how long will it take for the accumulated balance to reach $12,000. So our principal, what we're starting with, is the $5,500, and we want to end up with $12,000. And we need to figure out how much time is it going to take for this account to build up that much at an interest rate of 7.75%. So when I set up my equation, I put in my rate and I put it into the decimal. Here's my P, my principal, what we're starting with. This is our accumulated balance, what we want to end up with. That's the 12,000. And what we're trying to solve for is this T. Because we're trying to solve for a variable that's in the exponent, this now is an exponential equation. And if you think back, the way that we solve an exponential equation is we isolate the exponential part. The exponential part is this part here. It's the part with the base and the exponent with the variable in it. So the first thing I want to do is divide both sides by 5,500. So I'm going to have 12,000 divided by 5,500 is equal to e to the power of 0.0775 t. So now I've got my exponential isolated, and once we get the exponential isolated, what we're going to do is put it in log form now. So I have log with base e, since this is base e, 12,000 divided by 5,500, and that's equal to my exponent, which is 0.0775 t. And since this is base e, I can write it as natural log ln, and if I simplify the 12,000 over the 5,500, I would simplify that and get 24 over 11. If you don't want to simplify, you don't have to, but I definitely don't want you at this point to plug it into the calculator and round it and make a decimal approximation, because if you do too many intermediate steps with approximations, it's going to throw your answer off. So wait until the very end to round. Okay, so at this point, I have natural log of 24 over 11 is equal to 0.0775 t. So to solve for t, now I just divide both sides by 0.0775. So I have the natural log of 24 over 11, all divided by 0.0775. And again, if you didn't reduce it and you left it as 12,000 over 5,500, that is totally fine. But don't put it in decimal form that's rounded until the very end. Now that we have this completely solved for t, this is where you want to plug it into the calculator and round it. So I'm going to use the natural log button on my calculator, and I'm going to put in 24 over 11, or if you didn't reduce it, put in 12,000 over 5,500. That answer will give you 0.78015, etc. And then you take that answer and divide by 0.0775, and you get 10.066 years. So just a hair over 10 years is how long it's going to take for 5,500 to grow to 12,000 under these circumstances of compounding continuously in a rate of 7.75%. Now, previously, we weren't able to do that by hand, and what we did was we set on the calculator in one y equals, where you graph, we put the equation 5500 e to the 0.0775t, and then we put the second equation in, 12,000, and we look to see where they cross, and where they cross would be the answer. So in this case, if we did it on the calculator using the intersection method, where it would cross would be the 10.066 years. But now that we know how to do this by hand, we can check it. We can do it both ways and verify that we've got the right answer. The next example says atmospheric pressure P is in pounds per square inch and is represented by the formula P is equal to 14.7 e to the power of negative 0.21 x. And x is the number of miles above sea level. And let's also write down that P is in pounds per square inch. Okay. It says to the nearest foot, we want to find the peak of a mountain with an atmospheric pressure of 8.816 pounds per square inch. So they're giving us the P, and they want us to find the X. However, they're trying to trick us. Notice that they're asking us to give it to us to the nearest foot. And the way the function is defined, X is defined as the number of miles. So what we're going to do is once we figure out what X is in miles, then we just have to translate that into the number of feet to answer the question completely. Okay, so we are going to put in for P 8.816. That's our atmospheric pressure. And we need to solve for X, which is the height in miles above sea level of the mountain. So here we have an exponential equation. I know it's an exponential equation because I have X, what I'm trying to solve for, in the exponent. So when we solve an exponential equation, what we want to do is we want to isolate the exponential part, which would be this, and then put it in log form. So the first thing that we want to do is divide both sides of the equation by 14.7. So I'm going to have 8.816 divided by 14.7 is equal to e to the power of negative 0.21x. And once we have the exponential isolated, then we put it in log form. And I want to continue to stress that we're not going to put the 8.816 divided by 14.7 in the calculator and round it and do those intermediate steps. We're going to wait till the very end so that we only round once to keep the accuracy of the answer. So now we're going to put this in log form. My base would be base E, so log base E of 8.816 divided by 14.7 is equal to, and then I set that equal to my exponent. And I could also write this as natural log, since it's base E, if I would like. So now to solve for x, I'm going to divide both sides by negative 0.21. I'm going to divide both sides by negative 0.21. So I have the natural log of 8.816 over 14.7, and that's all divided by negative 0.21. Now I'm going to put this in on the calculator, and I'm going to do it all in one step. I'm going to hit my natural log button, and then in parentheses, I'm going to do 8.816 divided by 14.7, close parentheses. That gives me an answer, and then I take that answer and divide by negative 0.21, and I'm going to get an answer of 2.434663054. Now remember, this is in miles. The question is asking us to round to the nearest foot. So although this is the correct answer, we're not quite done with the question yet because we have to translate it into feet. Now the problem gives us the hint here that there are 5,280 feet in a mile. So if you didn't know that, you had that in the question. So all we have to do is take our answer of the 2.434663054 number and multiply that by 5,280, and we'll get our answer in feet. So our answer in feet would be 12,855.02093. Now it says to round it, let's see, to the nearest foot. So when I put this in on my, so when you answer this on your homework system, you want to answer it as your final, you want to put in your final answer as 12,855 feet. That would be your nearest foot.